Hi everyone, in this video we are going to solve a problem. The problem name is longest path with different adjacent character and the question number is 2246. First of all, let's try to understand this problem. Let's see what this problem says. You are given a tree that is connected undated graph that has no cycle. In this example 1 and example 2 you can see that we are having a tree that has no cycle, or we can say they are not making any loop, right? After that, rooted at node 0 consisting of n nodes number from 0 to n minus 1. So the root node will always have a value 0 and all the child node will have a value n minus 1 till n minus 1. So if let's say n is 6, so we'll have a value 0, 1, 2, 3, 4, 5, right? After that, it says that a tree is represented by 0 indexes array parent of size n, where parent of I is parent of node I, and since node of 0 is the root, parent of 0 is going to be equal to minus 1. So in this example, you can see that we have a parent array, right? In this parent array, the first value is minus 1 because that is 0 index. And in 0 index, you can see that always 0 node will be rooted node. So we'll have a minus 1. It doesn't have any parent. And after that, we have a 1 index that has value 0. It says that parent of 1 index is going to be 0. Here you can see that 1 index is parent 0. On the second index, we also have 0. So second index parent is also 0. On the third index, we have 1. So third index parent is going to be 1. And similarly, 4 index is also 1. And similarly, 5 index is 2. So simple guys, we have a parent array that help us to find the parent of any particular node. So let me move all these things. Fine. Now guys, we have you are also given a string s of length n where s of I is the character assigned to node I. So we are also given with the string s, that string tells us that what character represent to that particular node. So in that 0 index we have a, so it says that on 0 node we have a character, on index 1 we have b. So we can say on 1 index we have a b character. Here you can see that on second index we have a, so on second index we have a character. So similarly, this string help us to identify which character belong to that particular node. Fine. Now guys, in example 2 also you can see that same going parents and string, right? Now let's see what we have to return. Return the length of longest path in the tree such that no pair of adjacent node on the same path have same character assigned to them. So we have to return such path that path doesn't contain the same character adjacently. So in the first example, if I say you, then if we say this particular path is the longest path, right? But here, did you notice that A and A are same? Adjacently, they are same. So what we can say, this is not going to be a valid path. We can't have same character adjacently. So what we can do, we don't take this particular path. That's sure, right? Now we can take this particular path because A and B are different. After that, we can't take this particular path because B and B will be same. So we have to remove this particular path. So we can take only this path right now. And after that, we can take this path because B and C are different. Now guys, once we have taken this path, we can return 3. And why we are returning 3? Because we can see the first node is this, second node is this, and third node is this. We have 3 node, right? In that 3 node, we are getting a maximum path and we are getting a character A, B, C, right? You guys can see that not any single character having the same adjacent character, right? A, B. We can write A, B, C, A. We can take this particular path because A and A are same, but they are not adjacently same, right? But we can't take A, B, C. I hope this much making a sense, right? Now guys, what we can see that, let me remove all these things. On every node we have either can take this particular path or either we can take this particular path, right? If there are 3 nodes, let me make 3 node a, 2 and 3, right? And here guys, what we can say, either we can take this particular path, let me choose a different color as well. Either we can take this particular path, right? Or we can say either we can take this particular path, right? Or either we can take this particular path. But here, did you notice that from node we can take only one from left side and one from right side? We can't take one path is coming from there, one coming from there, one coming from there. We can just take one path from left side, one path from right side, right? So what we have to do, we have to identify from every node that which path is a maximum path from left side, which path is a maximum path from right side. Let me write the logic how we can solve this particular problem. So here I'm going to write the logic and I'm going to make same tree. So let me make it 0, after that 2 and 1, and 2 has a 5 and 1 has 3 and 4, right? Now let me assign the character as well. So let me say this has A, this also has A, B, this also has B, this has C, and this has nothing but E, right? So okay. Now guys, did you notice one thing? Let me tell you once. Let me make it. Now guys, we can see that from 0 node, find out the maximum left and right side, right? So from 0, we are seeing that find out how many maximum length you can get from the left side and right side. So it will come to 2 and it will say find out the maximum length from left and right side, right? So let me make a different color. Now it has nothing on right side, but it has left side, right? So it will come to left side and it will say find out the maximum length from left and right side. So it has nothing, it has 0, 0, no node, right? So it will say I have nothing, then I'm going to return 1, right? Because E is also a different distinct character. So it says still I have one path. Okay. Now it will return 1 plus 1 to this 2 only when, or we can say it is going to return 1 to parents only when they have a different character. E and A are different. So it will say that we have nothing but we have a one path. So it will say that just take my one path and add into your. So 2 is also one node. So it will say 1 plus 1 is nothing but 2. So far we have two maximum paths from this particular two node. And we can also visualize that 2 to 5 is nothing but two length paths, A and B, A and E, right? Okay, so let me remove this. Fine. It is going to say the maximum path I have nothing but 2. And it is going to ask from right side and there is no node. So it is going to return 0. So it will say the max path I am getting is 2 plus 0 nothing but 2. Fine. Now guys, this 2 is going to return its path to this 0 particular parent only and only when they have a different character. But you can see A and A are same. So this 2 is not going to return any part to this. It will say I have 0. Alright. So it is going to say 0. Fine. Now guys, after this, you can see that we have to ask from the right side as well. So 0 has asked from the left side and it got 0, right? It says that the maximum path I am getting from left side is nothing but 0. Alright. But you can see in our global variable, let's say global variable is nothing but result. So we can say in result, we have a maximum path right now 2, right? So we have find out a 2 maximum path from this left side is we are storing in our global variable, which will take a maximum value on every time, right? So now it will gonna ask from left side and it will say, okay, so just ask from the one what is the maximum part do you have from left and right side? So it will ask from 3 first of all. So 3 has nothing from left and right side. So it's going to return 1. So okay, 3 has one maximum path. Now this 1 is going to transfer to this parent only and only when they have a different character. And C and B are different. So 3 will say take my one path, right? After that 1 is also going to ask from right side. On right side we have a 4, right? And this 4 is also going to ask from left and right side, but they have nothing child, right? So what it's going to do? It's going to return 1. So 4 has a 1 maximum path right now. And you guys can see that this 1 is going to return to its parent only and only when they have a different character. But here you can see we have B and B are same. So this one is not going to return to this one parent. It's going to say I have a 0 path. So it will say okay, I have 0 path. So it say from right side I got nothing but 0. Now the total path it has nothing but 1 plus 1 nothing but 2. So we can say the total path is 1 plus 0. 1 is from left side, 0 is from right side and 1 itself, right? So we can say total path is nothing but 2. So this is also going to say till 1 we have a 2 maximum path and result is already having a maximum path 2, so we can't modify it. But now guys, this 2 is going to return to 0 only and only when they have a different character, right? So here we have A, here we have B. So we can say that A and B are different, so 2 is going to be written over 0. So 0 have nothing but 2 from right side. So it has 0 from left side, 2 from right side and 1 itself. So we can say that maximum path it got is nothing but 3, right? So it can say it can form a maximum path that is 3. So we are going to update our result because we can see 3 is greater than 2. So result is now going to store 3. And now guys, we can see that we have traversed every possibilities. Now we are not left with any child which we haven't traversed. So we are going to return 3. And this is the result we are getting from example 1, right? I hope guys you understood this. If you still did not understood, don't worry. We are going to implement this and there you will definitely understand how we are using this depth first search, how we are calculating this path and how we can implement this particular logic. So let's move to the implementation part. So here guys, first of all, we are going to define a dictionary that is paths and this dictionary help us to identify from that particular node where we can move. So initially I'm going to take it empty. So I'm going to say collection. Let me write a collection dot default it and by default it will contain a list, empty list. On every so why I'm doing this? You can see in example 0, we can see that from 0 we can move to 2 and 1. So I will store 0 on 0 particular index, 2 and 1 in a list. Alright. So now once I have defined empty list, let fill it. So I'm going to say for value in parent. Alright. What I have to do, I have to use indexes as well. So I can say for value comma index. So I'm going to say for index comma value and I can enumerate it. So for index comma value in enumerate, fine in parent. So what I can do, I can see that from that particular value, we can store that particular index. In this example, you can see that on one index, we have value 0. That means from 0, we can move to one index, right? And on similarly, on second index, we have 0. So from 0 also, we can move to second index. So I can see that from parts of that particular value, means on that particular value, we can move to which particular path? We can move to that particular index. So append that particular index. Fine. This will create our dictionary, which help us to identify all the paths from that particular node. Once we created a dictionary, we're going to use a DFS. So let me make a function, define sort. And guys, before that DFS, I'm going to create a variable that is going to be our answer. So we can say result. Initially, it will have a 0 length. All right. And this DFS, we are going to start from 0 value. We are going to start from node 0. Fine. After that, guys, see, we are going to traverse all the particular path and we are getting a left and right maximum path. And after that, we are adding 1 from itself and just that we are doing, right? We're asking every node that find out the left maximum, right maximum. After that, tell me, and after that, I'm going to add one more path and that will be the maximum path from that particular node, right? So what we can do, we can take two value, first max or we can say left max. So let make it a first max only and the right max or we can say the second max, right? Second max. And what it is going to do, it's going to take default value 0. So let me add 0, 0. All right. Now we are going to traverse all the paths that are possible from that particular node. So we can say for child in paths of node, all right. And after that, we are going to call same function again. So I'm going to say solve of child, fine. And this function is going to return the maximum path from that particular node. So we can say the max path is going to be right now this, right? Once we have done these guys, we are going to check if this maximum path is greater than our first max, that means our first max is smaller. So if first max is smaller, that means second max is also smaller. So we have to modify this two value. So we can say first max is going to be our maximum path, but before that I have to modify second max is also. Second max is going to be a first max. So second value is going to be going to store our first value, and first value is going to store our maximum value. I hope this much is making sense. If you're doing a DFS, then definitely this much is making sense. Else, what you can do, if this is not the case, you can check one more condition. Let me write elif. It may be the case that max path is not greater than the first max, but it must be greater than the second max, right? So what we can do, we can say that L if max path is greater than second max. So what you can do, you can update your second max also. Second max is going to equal to max path, but we are not going to update first max because first max is already greater than max path. That's why we come to this elif condition, right? Now guys, once we have done this, we are going to update our result, right? We can say that guys, result is going to be maximum value of result. Maybe already the maximum value is stored in our result. If it is not the case, then you can take this value second max, or we can write first max plus second max plus 1, right? And guys, one thing I have done wrong here. Did you notice that we will do only this when we don't have a same character? So we have to use one more condition, that is if s of node is different than s of child, right? Then only you can perform this function, otherwise you will have a zero value. All right, so we can say like this. Once we have done this, now we have updated our result as well. Now we can return our this particular path. So let me copy this thing. Just we are going to return, because this is our maximum path from that particular node, right? So let me write here. Fine, this is the function we have to do. So we are going to call from 0. So we can say solve of 0. Always it start from root node. Fine, after that we can return our result. So I hope this much is clear to you. Let's see whether we are getting any error or not. So here guys, you can see that we got an error, that is result, because we have used a result which is global, right? But here we are declaring a nested function, so we have to use a non-local keyword to access all the local variable. Now let's try to run this code, and hopefully it should not get any error. You can see guys, both the test cases are accepted. So let's try to submit this code and see whether it's working fine or not. We got a wrong output on which particular test case. Let's see this. What the error I have done. Alright, so I'm returning first max plus second max plus 1, right? But I can't return second max. You guys can notice that in this example. Let me show you. You guys can see that here, if I take both the path, so I can't return this both the path to parents. I have to return only one path, because this parent can move to in this two direction, right? It can take only the one path from that particular node. So let's try to submit this code now. And here guys we go. I hope you understood this solution. If you learned something new in this video, don't forget to hit the like button, subscribe my channel. Meet you in the next video.